Hey yo, what's up? Oh my God, it's been so long since I've gotten on here and done a stream. Uh, it's been a while. So forgive me as I kind of get things together, get things in order. Um, okay, so welcome back. My name is Key. I've done a series like this before. I did some like AI related stuff a while back, and this is kind of my return to the streaming world. If you're unfamiliar, OpenPair is just a series where I will basically be sharing my journey as I explore and learn and grow. And I encourage you to join and watch and to follow along if you want to. But the caveat here is that I am not an expert. The reason why I started this series, in fact, is because we're streaming and recording and all this kind of stuff. It helps me stay accountable on my journey. It helps me push myself to do more. And most of all, it's something I can look back on in the future to see my progress and my growth. If you have not tried it, streaming is a really great way to kind of like see yourself from the outside. When you stream, record, or explain things, it forces you to brush up against the boundaries of what you truly understand. So don't just watch me do it. I encourage you to do the same. So, anyways, this is a new series for GoLang. I won't go like super into depth about GoLang, but I can give you a little bit of a background. Let me just pull up the Wikipedia thing here and see what Wikipedia says about GoLang. We can read this together. Okay, so let's close this. Okay, so GoLang is a language that was created by Go. It looks like it was created back in 2009, and Go was created by the fine people over at Google. Oh, it looks like actually 2007. Um, so GoLang is a language that is, I would say, syntax-wise, very similar to like a lot of the C languages. If you've ever programmed in JavaScript, TypeScript, if you've ever used C Sharp or Python, there are a lot of similarities. It shouldn't be too crazy. Um, Although there are a lot of unique things about it. As far as like where it falls within like being either a high or low level language, I would say that it's probably somewhere in the middle. It has a lot of the features that are nice to have with high level languages. It's easy to like jump into, but also you can do things that will access some of the computer memory. So like there's like pointers and you can manipulate the memory as well. So that's kind of why I use it. It's like the best of both worlds. It's as easy as programming in like JavaScript or C Sharp, but you can also do things that are very optimized, very fast, and that have more or less some control of memory. And there's also some other useful features. I'm not an expert at this. I'm still learning, but that's kind of like my spiel. So this is a compiled, statically typed, high-level programming language, and it has a lot of the same features and capabilities of something like Python, but it is a lot faster. And my primary intention of learning this is because I want to be able to build servers in GoLang, really fast servers for web apps to do things that may be a lot slower if I were to build an Express web server. So that's as much of an introduction as I'm going to do. In fact, I am not going to belabor you with the details of how to set up GoLang on your computer. I would have you know, though, that there is a repo that I've created as a counterpart to this, and I will do this as I continue forward. This repo is on GitHub. The link is in the description of this stream. This is the README for that, and there are some links here. If you would like to install this in your computer, just go to the official website. If you go, actually go to just go.dev, that's the actual website. Click download here, download it for whatever system you have, and that should get you everything you need. It's not, there's no like super extensive process for getting things started. If you go to the documentation and go to user manual here, go to install Go, and this will give you the steps that you can go through as well. I'm using Go 1.21.4. I updated this today. So yes, if you have never installed a programming language before, Go is probably not a good one to start with. I'm just going to put that out there. If you have installed a programming language, or like the developer tools for a language before, then this should be pretty simple. I'm going to be using VS Code today. And in VS Code, there are, of course, some extensions that make this really easy, much easier and much friendlier. Um, Let me just show you what I have here. I just have the basic Go language support, and I think that's about it. There's some other stuff here. Personally, I'm a minimalist, or like I try to get things as I need them. So I don't have like a lot of the stuff here. I'm sure these are also useful. I just have not gotten to needing any of these things yet. If you want to have like the latest features for the GoLang support in VS Code, then you want to use the nightly build. But using a nightly build of anything comes at the risk of bugs and whatnot. So do that at your own discretion. Otherwise, the most supported bug-free version of anything is going to just be the regular version, which is this one here. So do all of that. If you have not done that and you want to kind of follow along, or you want to do this repos tutorial, which all the code will be there from top to bottom, organized. Make sure you do all of this stuff first before you move forward. Okay, let's just take a look at this overview. This is not a tutorial or class, but I am a teacher, so I can't help but approach things like that. I'm being my own teacher. Okay, we're going to take a look at variables and data types. So basically, how do you declare variables? And then just a quick run through, rather a sprint through some basic data types that we can use. We're going to talk about constants versus variables that can change their value. We're going to talk about control structures, so like if conditions and loops. We're going to take a quick look at that. That's a part that I'm rusty on, so I'm curious to see how that goes. We're going to look at functions, basic definitions of functions, and how to call them. With GoLang, functions also have you define the return type as you write the function, so that should be fun. Arrays and slices, so manipulating arrays, which are pretty important, excuse me. Maps are like the, if you're used to JavaScript, maps are like the object literal of this language, so key value pairs. And then structs, which are ways to define types. So if you have interfaces in TypeScript, structs are the GoLang equivalent to that. And then handling errors, and then also how to use defer and panic for cleanup, and also the panic for creating errors. So this is all pretty simple, pretty direct, pretty straightforward. I have some like just examples I'm going to walk through, and then I may need to at points Google and look up things, and that'll also be fun as well. So yeah, let's go ahead and start by getting our app working with GoLang first. One thing I need to do is make sure that my actual repo here has everything I need to run some GoLang code. So the first thing that I need to do in order to get GoLang working on my computer, after I have it installed, of course, is I need to set up GoLang, a GoLang module for this project. So you need to have two things. You need to have a go.mod file, and then you also need to have a main.go file. Main.go is the file that runs, it's like the entry file, like the main file that everything else kind of feeds into. Okay, so if you don't have a main Go file, that's like missing the main thing that needs to happen, hence the name. And then go.mod is the file that's going to contain the configurations for this project. It is comparable to like, I guess like a package JSON type of deal. Like in Node projects, package JSON is like the configuration file. That's what it's going to be for this, is the go.mod. So the way that we can get the go.mod is we have to initialize, okay? So actually I have an old command here because I have unfortunately forgotten what that is. Let's see. Okay, so here's a fun thing I learned recently. If you do exclamation point in your terminal, you can type in something that you can use to fuzzy search old commands in case you forget. So let's hope that works here. So I know it has something to do with init. Let's see, go. Um, oh gosh, okay, I'm looking silly right now. Let's just look this up online. Okay, initialize a Go project. Okay. Uh, okay, here it is. Go mod init, and then you have to create a. I guess this is like some type of path. This is really just used as like the namespace for your project when you make modules and stuff like that. I don't know the technical term for that, but let's just copy this and put this in our terminal, and we'll have to change this last part. So this is like this fourth part of this command is basically how you want to refer to your project. So I'm going to call this OpenPair. That's going to be like my domain name that I'll use for all my OpenPair projects. And then I'll just call it GoLang intro. I don't know. Does this need to be all lowercase? I don't know like what the specifications for that are. I'm gonna have to look that up later on. That's interesting. I don't quite know. One thing I will try to resist doing is using ChatGPT. I don't want to. I know like ChatGPT is helpful, but I don't want to like default to always going to it anytime something comes up. Okay, so now that I've entered in this initialization command, you can see here that it's created a go.mod. This is really simple. All this does is it basically will identify this project at the root level to be this OpenPair GoLang intro project. So all of my code inside of this project will refer to this module, and you can make submodules as well. But these modules sort of help track how everything's interconnected and related, and it'll allow you to bring in code from other files, which we'll do later on. And then also it has the version of GoLang. I'm using the most recent version here. Okay, so we got that part. The other thing that we need is a main.go file. I can just do touch in my terminal here, main.go. And this will be the file that actually runs my code. And I'm going to call this package main because that is what this is. Usually your main.go will always be package.main. Let me turn off Copilot too. I need to do this hard mode. There we go. Okay. I do use a lot of Copilot on my own because it just makes things faster. But the point of this series is to push myself. So I'm not going to use it. Okay. So in your main file, you need to have func. Func is for function and main. And when your program runs, my understanding is that this main file is always the first thing that runs, and then everything else happens as a consequence of it. So this is like the main thing that will always run first in your code. I have my notes off to the side, by the way. So if you see me looking, that's what I'm looking at. Okay, so all of your code will basically be a consequence of what happens inside of here. And let's just take a quick look at the way you do comments real quick. I know in VS Code you can always do command / and it'll automatically do these single line comments, but I think there's also a way to do multi-line comments. Let's see if I remember it actually. I think it's like JavaScript, so /**. No? No? Okay, let's look it up. So multi-line comments, GoLang. By the way, I have a cat, and she's in the background, and she is just very pressed for love and attention because she hears me talking to you. That's how it be sometimes. Okay, I don't like the way this looks. Let's go here. Okay, so it's just 1 star. Okay, I shouldn't have doubted myself. So comments can be either 2 slashes, so this is like JavaScript, or they can be /* and then // and then the stuff in between is also a comment. So like that. Capiche, capuche, caposh. Okay, so I'm gonna move this outside because I don't really want that in there. It's gonna muddy things up. Um, cool. I should get the little thing that lets you see like what my keyboard commands are. That would be really nice. I'll do that later on. Okay, so the first thing that we need to look at before we go any further is we need to see how we can run our code in a terminal, which is pretty easy and pretty straightforward, but we need something to actually run, and that's where console logs are going to come and help us. Console logs are always a really great way to debug your code, a way to see what's happening, a way to kind of get something running and going real quick. And when you're writing any kind of code in any kind of language, that's your first objective is just to see something happening. Okay, if you don't see nothing happening, you ain't going nowhere, or you don't know if you're going anywhere. Okay, so console log is usually one of the first things you want to learn when you learn any language. For GoLang, in order to do console logs, we need to do an import. So import is like this. So import and then a space, and then we can do the name of our import. For console logs, we need to do formats, which is FMT, like that. And then a console log is going to be fmt.println. Print line is equivalent to console log, so that means that any string within here is going to be on its own line automatically. So welcome to GoLang introduction. Woohoo! Okay, so now that we have this, let's go ahead and run this program. It's real simple. We should be able to just go to our terminal, go run, and as long as you're inside of the root of this repo, and there is a main.go inside of the root of this repo, then we should be able to do go run period, which is pointing to this folder, of course. And we can see here, this is our console message, so everything is good. It's good, it's Gucci, it's gravy, it's all those great things. I actually don't own any Gucci, and gravy to me is not actually a food that I would eat. But that's beside the point. It's neither here nor there. Okay, so this is how you do a console log. This is how you print to the console. There are actually other ways to print to the console. I actually have this open from earlier. You can do print. This will not create a new line. Print F will allow you to do a formatted print, so you can have your variables like this, and then you can have them injected into your string and use a percentage and these letters to indicate exactly what type of data that you're injecting into your formatted string. I don't use this. I'm sure somebody does. I'm sure there are situations where that's super helpful, but I have not found a use for it yet. I'm personally more likely to do this. This is more just like concatenating, but use what's helpful, okay? So this is just the basic approach right here. Okay, so let's put some space here because I'm going to do a bunch of stuff, and this console is going to get pretty filled pretty fast. So let's keep this cute. Let's keep this neat. Remember, \n creates a new line. That is an escape character. Ooh, what's it telling me? Oh, it doesn't like me doing the new line at the end. I'll put the new line at the beginning of the next thing I make. How about that? Okay, so let's talk about variables and data types. So let's look this up. Variables for variables and data types for GoLang. Let's just look here. So let's see, data types right here. Okay, so GoLang has all these data types. We don't really need all of these, but it has all these numerical types. For today, we're just going to use we're not going to really focus on explicitly typing things because GoLang is really good at determining what the type is. But just know that you will be able to have a certain syntax when you declare a variable where you can include information about the data type that you want to use, which could be helpful in some situations, especially where you have to do like type correction and stuff, or you want things to be turned into a certain type after a calculation's happening. We won't worry about that too much. I'll show you an example with like something, but I'm not going to go into all this. There's numerical types. There's string. String is like all strings. There's array types. We're going to look at just the basic array here, and I think we'll revisit this later on in another stream. Really, we won't go into like all these types, but just know that if you want to use these types, just read the documentation because this is very different from like JavaScript and Python. You have to be really explicit, and some of these types here do have limitations. Okay, so this won't really be a point today, but maybe we'll revisit that later on. Let's just go ahead and jump in. I'll make a little header. I want to keep this real neat here. So fmt.print line. We want this new message to be on its own line. So \n, escape character. And this is going to be number one, variables and data types. Okay, so let's run this one more time. Okay, that looks good. Perfect. Okay, so var, name. So name is the name of our variable. Name could be taco cat. Name could be birthday, or I'm sorry, variable could be birthday. It could be whatever you want to name it. We're just going to call it name because we're going to do this with the person's name. And then the third thing here is the actual type, right? So in this case, it's going to be a string. Okay, so variable var, this means that this variable can more or less change. Yes, that means that this variable can change. We're actually declaring this variable on this line without assigning it. So it's going to give us a little error here because it's not being used, but you don't have to assign a variable in the same line as long as you use var. You can actually do the assignment on another line or do it later on. So this will be undefined until it is used. So in GoLang, you declare variables using the var keyword. Okay. And this is declaring a variable of type string named name. Okay. Let me make sure my stuff is consistent here. Okay, so there's that. Next thing is that we can use the same variable and we can assign the value later on. So to do that, it's just name equals, and we'll use John as an example here. So now that's been assigned. Perfect. And then, of course, we can print this now. So fmt.print line, and then let's do name and name. And let's see, do we have an error here? Should merge variable declaration. Okay, so what this is saying here is that in my IDE, in VS Code, it does not like that I have declared and then assigned separately. Let's go ahead and run this first. And you can see here that it works. This is more of just like a styling thing. There are situations where it makes sense to like do the assignment later on. So let's not worry about that for now. Just know that this is perfectly fine. What's the quick fix do? Okay, yeah, it wants us to do something else. In GoLang, you declare variables using the var keyword. Yeah, this is fine. The main thing here is that this does in fact work, and we can see that right here. Let me just quickly do something really quick. I want to make sure there's like space between my console and the next command enter thing here, because I just feel like that's going to be easier to read. So let me just fix that up real quick and like that. So let's Actually, I think I could just leave this empty like this. Let's see. Yeah, okay, so this is gonna look a lot nicer. This is because this is gonna build up and we're gonna have a bunch of stuff here. Okay, so the next thing here is that we can do the assignments on one line. There's actually a shortcut to declaring a function and assigning, so let's try that. So age, and the shortcut is colon equals, and then we'll just do 30. So we can print this fmt.print line, and then age. So notice here we didn't have to do the var part. This is the shortcut way. Now, I don't know if there are like some like nuanced distinctions here. I haven't done this enough to know. We'll see when we see. Let's run it. Cool. So now we got age 30. Cool. So what's next? Okay, so GoLang supports, like I mentioned, types that are integers, float 64, string, boolean, all those other things. Those are all cool. Let's make a boolean real quick. So just like before, var is student. We want the type to be a boolean. So boolean is bool. Excuse me. And false, because I am not a student. I am a teacher. Professionally speaking, at least. As far as GoLang, I'm a student though. So fmt print, and then we can print is student. Whoops. Is student. Let's actually make this correct English. So like that. And let's run it. This student is false. Cool. Capiche? Capuche? Capash. Okay, so now let's do the other type of variable declaration. So this is var. Remember, var means that it can change. When you declare with var, the value can change. Yeah, okay. Now, the other way that we can do this is we can use constants. Constant variables cannot change their value. If you're used to JavaScript, this is like a const. It's pretty similar. Now, I'm not sure if there's like the weirdness of like dealing with arrays and objects, how there is with JavaScript. I don't know. That's something I do need to look into though. So yes, let's go ahead. Let me make a little header for this first. So fmt, we're gonna do this a lot. Print, and this is going to be to a new line to constants. Okay, so to do a constant, it's const. And for this one, we're going to do pi. And we're going to assign this to float 64. We want float 64 to contain the digits for the number pi. So pi is 3.14159265359. I think that's pi. If it's not, don't tell me. Let me live in my delusion. Okay. So fmt dot print line, and then let's go ahead and print the value of pi. Like that. Okay, let's see how this looks. And we can see here that we've now printed the value of pi. Because we define this as a float 64, it has preserved the decimals here. Let's just see what happens if we make this into an integer. Let's go back here and see the declaration for integer. So GoLang integer. I spelled integer wrong. Because there's different types of integers. Let's try int 16. Yes, let's use an int 16. Now, I kind of know what's going to happen, but let's see. Yeah. So it's giving us here an error. What it wants to do is it because this is bigger than int 16 can be, and what it wants to do is truncate this, and it's also throwing an error. So just know that whenever you're using a certain specific data type like int 16, that it has a limit to like how much data can be held there, and if you're making something to exist in that variable that is bigger than that amount of data, it'll get clipped off or it'll throw an error. I think there are like workarounds for this, but I don't know them. So just remember to look at your log here. This message here is just saying that it's truncated. So let's go back. Use float64. I think we're good. One second. I do want to try and see what happens if we use int 32. I wonder if that's going to do something different. Let's see. Yeah, it's going to break too. Let's try this. Yeah, so make sure you know what data type you're going to use. I don't believe you have to. Did my mouse just die? Oh, dang, I think my mouse just died. I got a cord here. Now, I don't think that you have to use a declaration. You can let GoLang just like figure that out for you. And that is a valid approach as well. So let's just get rid of this type declaration in general and let's see what happens. And we're just fine here. So if you don't know, like if you're working on some code and you're doing some crazy stuff with numbers and you're like, oh, I don't know what I want to do with this, just you could get by without declaring it. There may be some like performance stuff that happens there, but for like simple stuff like this, don't worry about it too much. Okay, let's keep float 64 here though. Okay, so that's cool. Let's move on now. I don't want to be on all night. Got stuff to do. I did martial arts earlier. I'm a little tired. Let's do control structures now, though. So control structures. When you hear control structures, sometimes you'll hear another term, which is control flow or flow control. That usually is just like things like loops and conditionals. So you're just controlling the way the code goes down. So think about code as happening usually line by line. It executes line by line in order of instructions. Control flow is like looping things. So the flow is that it just keeps going in a circle. Or if you're dealing with conditionals, the control is like, okay, do I want to do this? If not, I do this. If not, I do this. So think of it like, so the control flow could be doing stuff like this, or it could be doing stuff like this. That's how I envision it in my wacky cartoon mind, at least. Okay, so let's make a new section here. I'm just going to copy this, actually. Let's just see if this is even worth my time to be lazy, because I have to edit this so much that it might not have been worth it. Control structures. Okay. Yeah, I probably could have just typed that out. Okay, so let's first do conditionals. So conditionals, which are if-else statements. And to do this, we need to start off by having some type of variable. So let's use the shortcut assignment operator, which is colon equals, and then let's make this 10. So x is 10, okay? And for a conditional, if x is greater than 5, then we want to do the curly braces. These are the block scope of our conditional logic. And if it's greater than 10, then we can just do format, print, line, and then let's just print x is greater than 5. Okay. Whoops. There we go. So let's go ahead and run this. And you can see here x is greater than 5. And then we can do an else and fmt.print line x is less than 5, okay? Actually, that technically it could be equal to 5 and go down to this else. So let's just say not greater than 5. That's more accurate. So let's change this value to 4, and we should see the second message now for the else statement. And we can see that here. X is not greater than 5. Cool. So if else is pretty much the same as it is in JavaScript. I believe that you can also put parentheses around this. So if you have like really complicated logic here and you want it to be on multiple lines, the parentheses will contain those multiple lines or the compound conditions there. So do it to your heart's content. Go crazy if you want to. Go bananas. Okay. Cool. What next? Let's try a loop-de-loop. Okay. So um, loops. Let's just do a for loop for now. There's other types of loops. There's the while loop as well. We won't do that today. We'll come back for that one. Okay, so fmt dot print line, and then let's do escape in, and this will be number 4, loops. So this is annoying to do, but we'll be happy that we formatted all of these little console logs later on when you run this code on your computer and you want to see all the beautiful messages. Okay, so this is going to be like a traditional loop, like this is like computer science programming 101 type of loop. I think there are fancier loops. We'll see when we get there. So the first thing with the loop, let me explain this. This is what I was telling my students with JavaScript, is that a loop has 3 parts. The first part of the loop is the initialization of the index. So this is like the I part of a loop. This will help us track the index that we're at if we're looping through like an array, or if we're just looping through a series of things. This will help us keep track of which thing we're on. So you always do initialization of index first. The next part is we have to do a condition to control how long the loop goes. And the last thing here is, we have to increment the loop so that it continues forward according to some formula. And mostly you're going to see it just incrementing by 1, but there could be other patterns. I've never used any other patterns other than incrementing by 1, but you could go in reverse, I suppose. You could start at the end. You could start at like the length of an array, and you could do -1 all the way backwards if you wanted to. That's also valid. But I've honestly never done that before. Okay, so to do this for loop, it is for, and then initialization of the index. We can use the shortcut assignment declaration syntax here, and we'll set that to 0, assuming we're starting at the 0th index of something. And then we'll do I. While I is less than 5, this loop will run. And then lastly, every time this loop runs, we'll do an increment of 1, so which is I plus plus. And then our entire loop logic can go inside of the curly braces. Now, remember with this, you can still do the parentheses here, I believe. Oh, am I wrong? Wait, I'm tripping. Let's bring out the GoLang. So for loop GoLang. This literally happens to me all the time. I promise you, I've been coding for a while, but I still be get confused. You know what I'm saying? Wait, so you can do a for loop without the parentheses? I don't know why that just makes me like a little nervous when I see that. Maybe that's like a GoLang thing. I could have sworn. Oh, so maybe GoLang don't like the parentheses around the thing like that. Okay, I'm just saying. I mean, that's the way you want it. Okay, I'm not gonna argue too much with it. That's it. You know, do it like this. No parentheses around this. That seems weird that would it would take issue with that, but that's how it be, apparently. Okay, so we could put the logical inside of here. For now, we're not gonna do too much. we're just going to do fmt.print line, and then we can do iteration, and we can just see what happens with this index value every time we go through. So let's go ahead and run this. And you can see here that these are all the loops through. And this is only going to run while I is less than 5, so this will take us up to 4. But remember, this will also include the 0th index, or the 0th number, which is the starting value. Capiche, caposh, capoosh? Good? Thumbs up? Awesome. Okay. By the way, I'm so excited that I'm streaming again. I don't know why it's taking me so long. I've not done a stream in like a year. And I could have swore that I was going to keep doing these. I did like 7 of them. And then I got a job, and I was like, okay, I guess I got to focus on this. And I haven't been on this thing in a while. So my heart is racing. I'm so eager. I think once I start getting into this more, I'll be able to relax a little bit more and be like less jittery. But we'll see. I ain't going to judge it. Hell, nobody's going to watch these hour-long streams anyways. You know what I'm saying? It is what it is. Okay. How far are we? We still got a little ways to go. We're about like a third ways through. Okay, we may take a break here in a few moments. We'll see. Okay, so what's next? We did loops. Let's go to functions. Functions are fun. Okay, so functions. Okay, so fmt.println. You know what? I'm just going to copy this from my notes here because this is going to take too much time if I don't do that. Okay. So for this, we have to make a new function, and I'm going to write out the use of the function, and we're going to make the function separate. Okay. So what we want to do is we want to have a function that's going to return a string, and we need to provide this function a name so that it can construct a sentence for us. Okay, so a function that will take in a name and return a sentence, which is assigned to a variable. Okay, so let's do our shortcut declaration assignment. Greeting is the name of our variable, and then the name of our function is going to be called greet, and we'll be passing it a name. That name will be Taco Cat, okay? If you know me in real life, you know I love a good taco cat. I love a good taco, and I love a good cat, but I never had a taco cat before. It actually sounds kind of disgusting. So fmt.print line, and then we'll just print our greeting. Once we get that set up, it's not going to work right now, as evidenced by this undefined greet, okay? So let's go ahead and make this greet function. Let's make this outside of our main function, okay? Doesn't need to be inside of it. Let's make it separate. To declare a function, let's write a comment first. So greet is a simple function that returns a greeting message. I'm kind of tempted to do like the encode documentation for a function, but I don't know if that's in the scope of today's. Let me just look at it real quick. Function documentation, GoLang. I'm trying to make sure. I know I have an example. Give me just 1 second. Give me just 1 second of awkward silence while I look this up, because I know I have an example, and if I can just pull up one of my examples and I can just like kind of squeeze it in here, it can get squeezed on up in here real quick. Otherwise, I can save it for later. 1 second. Oh yeah, I think that's easy. Let's try it. Okay, so let me just declare the function first, and then I'll show you how to do the documentation part. So to declare a function, it is func, like funky, greet, and then you have the arguments or the parameters. So we have just one here. It's called name, and then you have to put the typing of the incoming argument, which is going to be a string. So you could have multiple, and then you would just, you know, make them like this, right? Or it'd be like int. So you do it like that if you have multiples, okay? But we only have one in this case. And then curly braces, of course. Oh, we're missing something. It's not going to throw an error if we miss this, but in GoLang, you can declare the type of the return value. So in this case, it's going to be a string that goes in between the definition of the arguments and then the curly braces for the block scope. So usually you want to have this here. This makes your use of the functions more type safe. Okay, so for this function, we're going to make a little sentence here. Hello, and then plus name plus exclamation point. This is gonna be like a cute, saying cute little sentence or whatever. Okay, so let's run this first and see what happens. We get hello taco cat. So this right here, we're printing, and it's running this function. Okay, so let's hover over this. You can see here, if we hover, it will actually take the comments above the function, and it'll give that to you as like little documentation here, and that's like super neat. There are things you can do there. If you were to turn this into a multi-line comment, you can get real wild and crazy. So we could say this function takes in a name and will um, return a sentence with the value or with the incoming name as a greeting. There you go. I really want to find. I know that there's like a way where you can specifically point out. Um, Maybe I should do this later. I know there's like a way where you can specifically point out information about the actual arguments and stuff like that in the comments. Um, Let me see. I think it's in. I'm looking at my GitHub right now because I built a server and I know I did a bunch of stuff like this. I just don't want to spend all my time digging through this right now. Let this also be a testament to the fact that you probably should not spend so much time using um, ChatGPT for a bunch of stuff as you're learning it because you'll run into the issue that I'm kind of running in with GoLang where it's like you've made a bunch of stuff, but then like your ability to remember the nuanced details of what you've made can be a little like shaky. And that, I mean, that's fine if you're making things just for you, but if you ever plan on like getting a job with something, you do not want to do that. In my case, I don't have an intention of like going and getting a job in GoLang, so it's not like a huge thing. Um, Let me just stop being lazy and like actually just see if I can find this with you here. So use comments. Let's use Google. So use comments to document function return type GoLang. Let's see what comes up here. Hmm. Hmm. I really don't even know like how to search this up here, like exactly how to phrase my search for this. Hmm. Hmm. Let me see what happens if I just do this. Okay, I'm going to come back and talk about that later on. This is really interesting to me because as I've gotten more proficient with coding, in code documentation seems a lot more useful, especially when you're working on bigger projects, because it allows you to like keep track of what's happening without going back and forth between files. I know a lot of times these block comments that get rendered inside of this little pop-up more or less will kind of function just like Markdown. Actually, let's see. If I just put those in backticks, will that actually render like code? No, no. Okay. Well, we'll come back to this later on. Awkward. Um, what I would do is here, even if you don't have it working the official way, it still could be really helpful to just put something here. So we'll say args, and then we'll say name, type string, and then we'll say returns, and then we'll say for returns it is a string. Cool. And then that at least will help us for the time being. So, oh, it actually likes this and then returns type string. Okay, looks like it did something here. I don't know. What if I put this on the same line? What's that do? Huh. Okay, well, this is better than nothing. How about that? Okay. Like I said at the beginning, I'm learning just as you're learning. We don't learn together. Okay, so this is our function definition here. We're calling the function. We're assigning to a variable. It's printing. We can move forward. We can move forward. Okay, we have permission to let go and keep it pushing. Okay. Okay, so we got the function stuff working. Let's knock out maybe two more things and then take a break. Okay. So the next group here is going to be arrays and slices. So arrays are indexed collections of things, and then slices is how we can make a selection of that and then produce a new variable that can be that subsection. So um, yes, so arrays inside of GoLang have fixed sizes, whereas slices are dynamic. Okay, so let's make a new array of numbers. So numbers, and then this will be, we might make this a size of 5. Okay, so we're declaring the size of this array when we create it. Int, and then will be 1, 2, 3, 4, 5. Okay, so declare an array with 5 integers. By the way, I said something wrong a second ago. I said slicing is uh, it can be multiple things. I think in Golang it's kind of confusing because a slice, and you're going to see here, a slice is a way to take an array and to just give you a subsection, but also slices are dynamic too. So that I think it's just better to show you. Some languages have mutable collections, and some languages have like immutable forms of that. So I think that's the part that can be confusing. This right here, this is immutable. Okay, so just remember that, I guess. So mt.println. It's funny because I'm approaching this like a teacher, even though I've established that I am not an expert. I think teaching must be a personality. I really think that because it's like compulsive for me to do this. Honestly, like I came into this like I prep talked to myself earlier. I was like, okay, you're nervous. Like you don't want to look a fool. Just remember, you're not teaching. You're just sharing your journey. Breathe. Okay. Okay. So we have. Let's console log this first, and then we'll do the slicing part. So you can see here we've console logged the array. The console log does not put the comments here, but just know that these are all separate values here, and that is this right here. Okay, now we can make the slice. The slice is we're basically going to take indexes 1 through 3, and then we're going to put them in a new variable called slice. So we're going to do the curly braces on the variable name for this array. We're going to start with the first index, right? So that is going to go all the way to um, ugh, so 3, so colon 3, and then uh, let's do 4 actually. 4. So that gets to the third to number 3. Basically, what we want to get is like this right here, I think. Let's see what this does, and then we'll come back and talk about it. How about that? Okay, so fmt.print line slice, and then slice. And what is this telling us here? Unidentified number. Oh, it should have an S. Okay, let's run this and see what we actually get. So 2, 3, 4. Okay, so remember, GoLang is zero indexed. Zero indexed, meaning that this is going to start. Number 1 is actually this. So if we want to get numbers 1, 2, 3, 4, we had to do 0, and that'll take us through the first. Let's see. Yeah, so the slice is now 1, 2, 3, 4, 0, 1, 2, 3. The slice will not apparently not include the last. So this is like the 4th index. It'll include everything before that. So if we change this to 5, so 0, 1, 2, 3, 4, and assuming that there would be a 5th here, there's not, so it'll actually just go up to here. So this should get us 1 through 5, like that. So if you're trying to figure out like how far this slice will go, just remember that it's always 1 less than this number here. Like the slice is including on the inside, but not. Does that make sense? Like, how would I visualize that? Maybe I can do a sketch. This might be backwards. Let's see if this even looks right. If it doesn't, then oh, it does. Okay. So if I do a slice and I go from 0 to 4, so right. So if I do 0 to 4, the slice will actually be 0, 1, 2, 3. Right here, this is 3. And 4 means that there could be numbers like over here, but it'll do everything before the 4th index, right? So it'll be everything over on this side. Slicing is one of the things where I was never, I have to do trial and error when it comes to slicing. I'm just going to admit that. I don't do enough of it to just have it in my mind like that, I guess. So just remember the index is always going to be everything on the inside of the end number. Okay, so if you do 5, it's going to go to 4. It's going to include 4, but not 5. Let's write a comment here. Slice will only include everything in front of the end index. So if you do 5, we'll get indexes including up to 4. Okay. In my mind, I visualize it as a wall. When you say 5, the wall goes in front of the 5. If you say 4, the wall goes in front of the 4. If you say 3, it goes in front of the 3, but it does not include it. The wall is like saying, which one of you am I blocking? Well, who am I blocking today? Who's going to be right on the other side of the wall, okay? The slice is not friendly to whoever is right here, okay? I believe that there may be a third thing that you can put in here. Let's see, slice, GoLang. Sometimes I be getting mixed up because I program in like TypeScript, JavaScript, Python. I do a little C#. So in my mind, it gets really, really, really tricky to organize all that in my head, which is why I'm very dependent on documentation here. Let's go down to slices. I just know that in Python, there are actually 3 things you can put inside of the square brackets because you can do, instead of assuming that your slice is going to include every number sequentially, sometimes you can do like skipping a number or like do every 2 numbers, every 3 numbers for the slicing as far as how to count forward. Um, where is it at here? Slice. Uh, I think they're called intervals. Let's Google it. GoLang slice interval. Oh, child, it's been a hour. Okay, I gotta take a break here in a second. After this, let me just try it. It's funny. I have students, and they always ask me questions. I'm like, just try it and see. I think this is gonna not work. Yeah, this doesn't work. Okay, so I guess maybe GoLang doesn't have that. Resist the desire to go to ChatGPT. Okay, just don't do it today. Don't do it. Don't do it. You can do it tomorrow. Okay, so short story. This is how you slice. We're not going to worry about the interval thing. I feel like that's a thing though, but maybe that is just handled differently in GoLang. There's probably a function or something. Um, that's surprising though, because I feel like that is something that should just be in the syntax like it is with Python. But whatever, whatever. I don't make the rules. I just follow them. Okay, so we're about halfway through with this. When we come back from our break, which is just going to be like 10 minutes or whatever, you can skip forward because ain't nobody in the stream. So y'all can all skip forward. We're going to come back. We're going to do maps, which maps are like dictionaries. So key value pairs, basically, they're like objects in JavaScript. We're going to do structs, which are the way to create types, like custom types. Then we're going to do a little error handling and defer panic. Defer panic is not my strength, but we're going to get through it. And then I think that should be it for this stream. And then I'll give you some details about what we got coming up next. So stay tuned. I'll be right back. I ain't got no break music, so I guess you guys sit in silence. Okay, peace. Hey y'all, so we are back. Okay, I got me a little applesauce and some water. I don't want to drink too much. I gotta make it through the rest of the stream. Okay, we're talking about maps now. Maps are a way to store key value pairs, and I think I will probably come back on this topic because there's a lot you can do. But let's just go ahead and jump into this in a simple way. So, for a map here, let's go ahead and let's make a map of fruits. So like basically a dictionary of different types of fruits. Let's call this fruit map. And what we're going to do is we're going to assign this. For the assignment, to create the map, we do map. And then we'll do string. So string is the type of the keys. And then I think you can do other data types. I'm not really sure what context you would do them, but we're going to treat this like a regular normal object that we would use. So we do int. Int is the value type. And then I I know like you can leave this if you wanted to. You could do the make. I'm getting this mixed up. We're missing something. Okay, so there's two ways to do this. This is like the way that you would do this if you want to just literally create a map and then have some pre-made key value pairs. So we can do apple 5. We could do orange. And let's do 10. Okay, so this is how you could do this if you literally just wanted to have a new map where you have values. If you don't want to declare the values, then there's like an alternative way you could do this, which would be like fruit map equals, and then it'd be make. And then inside of here, we could do this part right here. So if you do the make method and then you put the map stuff on the inside, this will make an empty map for you. Actually, let's console log this so you can see what we're talking about here. So let me just go ahead and get my little console log out here for you. I think we should be able to console log this. fmt.print. Let's just put fruit map in here and see what happens. So you can see here that this is empty. This is an empty map. Let me uncomment out my other one with the key value pairs. And you can see here that this has the stuff in it. So just remember, there are two ways to declare the empty way. So let's put a comment here. To declare an empty map, use make. This is how you create a map. Let's call this a literal map with assigned key value pairs upon creation. Okay. So in either situation, you can continue to add new key value pairs. That's pretty easy. So fruit map curly or the square braces, and then we can just declare the name of a new key. Let's call this banana, and then we'll say this new banana equals 7. Okay, so console log this. Now you can see banana has been included in here. The thing to know about these maps is that the order of these key value pairs is not guaranteed, so you should never base any type of logic on the assumption that this order is going to be as it is printed here. I don't know the underlying machinations, but this is true for like any language with dictionaries, maps. These are called unordered lists oftentimes. Okay, so you can actually update an element to have a different value as well. So let me add a comment here. Create a new element in the map, and then we can also update an existing element in the map. A fruit map. Let's do apple, and then let's make apple 6. So we should see Apple is 6 when we run this again. Apple is now 6. Cool. Okay, so we can loop over a map. Even though this is not indexed or ordered, we can still loop over everything. So let's do a for loop. So for, this is going to be another way to do a for loop. This is like, this is equivalent to a for in loop for JavaScript. So for fruit and quantity, colon. So these are going to be the two variables that we have access to within the context of this loop. And then we'll say range. Range means that we want to go over all of the things in fruit map. And then for this, we can format print. We'll do printf because we want to have some variables injected into our console log. So fmt dot print f for formatted print. And then we'll have a string here. I'm gonna do this in like opposite, the like reverse order. So the first thing you have is a string, and then after the string you have your variables that are comma separated that you want to be injected back into the string. Oh wait, this way, back into the string. So for this we'll do fruit, and we'll do quantity. And then the way that we create the string here is $. This is going to follow the type of these. So if you hover, you can see that fruit is going to be a string. You see a quantity is going to be a number because fruit is this, quantity is this part. So it's going to be $S, and we're going to do sorry, it'll be percentage sign, not $. So percentage sign S and percentage sign D. D, I believe, stands for digit. So where this dollar or where this percentage sign S is, that's going to correlate to this, and this percentage D is going to correlate to this. And I believe that this happens, the order in which you inject is going to follow the order of these variables here. Okay, so let's go ahead and run that. And you can see that is right here. So this is before our map is printing. Let me reverse this so this probably makes more sense. There we go. Okay, so run this, and you can see here that now it's printing out this here. Just to prove that this is actually working, I can say fruit. Okay, so yes, this is how we can loop over all of the things inside of a map and print all of them. Just remember this first part here is this first variable here is going to be the actual key, and then this will be the value. And a pair of these will be produced every time this loop runs. And then this range part right here, this is what lets us go over the actual map. So you got to know what map you're doing this over. Okay, so the range fruit map. Okay, so last thing is we can actually check, or the second last thing, we can check to see if a key exists. So we may be trying to do something with a big map that we can't read with our human eyes, and we want to know if something exists before we move forward, like a conditional or something. So we can do if quantity. Okay, and then that fruit map. What do we want to check? Let's check and see if Apple exists. And okay. Ooh, I think I might, let's see, I think I might end up struggling to like explain this. This might be one of those things where I'm just gonna have to like do a little search in here real quick. fmt.print line Apple quantity. Let's run this first. Ooh, that extra thing there. Let's run this first and see if this works. Okay, let's see what happens if I don't do this correctly. Let's put taco. Taco is not a fruit. And this does not run. Okay, so to kind of break this down, um, oh, we can actually put okay in here too, just so you can see what that does. So what happens here is when we do this, um, colon equals on the actual um, map here, what we're doing is we're destructuring two variables. The same thing's happening here. We're just destructuring two variables. So we're destructuring two variables by checking the key of apple on this fruit map. If this exists, then we will be able to get the quantity, which is the value of this key, and then this OK is actually just a true or false value if it exists. If it exists, it'll be true, and we'll get the quantity. If it does not, we will not be able to get the quantity. Quantity will um, it'll be, I think, undefined. No, I don't really know exactly, but this OK will be false. So that in that case, this will not run. And so um, use this if you don't really know the exact stuff that's included in a map, but you want to potentially do something. This is good for like validation. So to check to see if something exists inside of a map or condition. Good for validation. Just remember that when you do something like this two variables, colon equals, and then something on the right side, this is just destructuring it. That means that this something underneath the hood allows this to produce these values. I actually don't know how it works with GoLang. I'm familiar with this in JavaScript where you have an object and you can or you have an object where you have like a method or a function that returns a value, and assuming that it returns two, you capture them like this. So I'm gonna have to look into destructuring. Let's just take a quick look actually. Yeah, that might be something to look deeper into later on. I don't want to get too caught up in that. Okay, so just know this works. And let's move forward. The last thing here with maps is that we can actually delete an element as well. So delete is pretty simple. Just delete, and then the name of the map you want to delete something from, and then the name of the thing you want to delete, which is the key, of course. We want to get rid of orange. And for this, let's go ahead and print our fruit map again. Let's take this thing up here. We should see orange not exist like it was before. So orange, oh, that didn't work. What happened? Oh, it did work. So here, you don't see it. Let's do a print line before so you can see before and after. I think that makes it a little easier. So you can see here it existed, and then we can actually clean this up a little bit. So we can say in our message here, about to delete orange. There you go, about to delete orange, and then we deleted it. Okay, cool beans. Okay, so next thing is structs. Structs are the way that we can create type definitions, custom types, which can be really useful for enforcing type strictness, but if we're like writing our own code and we're doing like all sorts of weird stuff. So let me get this set up here. Okay, so structs allow you to create your own custom data types. The way this works is we do type, we give a name to the struct. Let's call this person. Think about a struct as a way to define like the way that an object or a map could be structured, right? This is a common use of this. So struct. So maybe the first property of a person would be the name, and the name would be a string, like that. The second property of a person would be the age, and age would be an int, which is a number, a whole number. And then the last one is human. Uh, Last time I checked, most people are human, but I guess a dog can be a non-human person or non-person human. Wait, non-human person. That's how you say it. Okay, so Boolean, right? So now I can actually use this struct later on to help with type enforcement if I were to create a new object or a set of key value pairs. So let's make a new person. So this is kind of like making, this is kind of similar to making a class. This is almost like making a construct in an object. I'm not sure exactly what the difference is. I'm not that advanced yet, but it's giving me that vibe. So person equals person. We're going to use the struct, so we got to call it first. And then we're going to give it the actual key value pairs. So let's say Charlie. Charlie's age is 25. And then is human false. Charlie's not a human. So let's go ahead and print. Hover over this too, and you can see that this here, instead of being like a map or something else, this is actually a custom type, and this type is person. So we can fmt.print, and we can say person, person, and let's go ahead and print that. So we can see here, we have a person, and we have all of the things about this person. Let me fix my little header up here. This should be structs. Why does this still say maps? Did I do something wrong? Oh, I know I did it wrong. My bad, my bad, my bad, my bad. Let me fix this. There you go. Okay, structs. Cool. Now, I want to try something real quick. I don't know, like, can you do person? I don't think you can actually add new keys to this. I think this is, well, let's just see. So if I take person and I do this, taco, cat, I don't think you can do this. So like you could do this for a map like we did right here to add or to edit something. I don't believe you can do this with a struct. We're getting a syntax error, but let's just see what the error message is. Cannot index person. Yeah, so let's see if you can reassign though. I guess it doesn't like that. Yeah, that's interesting. Okay. So it seems like there's some immutability stuff going on here. I'm not quite sure. Honestly, I've only like built two servers with GoLang and then done like some other odd things. So I haven't really used structs a lot for this context. Usually when I make a struct, it's for something where I know for sure that I'm receiving something that is of the same type as a struct. And I'm just using the struct as a way to define something that's going to be received and that needs to have enforcement or validation. I have not used it for like mutating or anything like that. So, but I was curious, so it was worth a try. Okay. So this is struct. Struct just allows us to make a custom type. This is going to be something I'll definitely have to come back and revisit. Yeah, this is a pretty integral part of GoLang, just from what I've gathered so far. This is like a core thing. This is a core thing in a lot of languages, honestly. When I've done like work with Java and Groovy and TypeScript, this kind of thing was super important. Okay, so last thing here is error handling. Okay, not last thing. I'm getting a little ahead of myself. Got error handling coming up here. Error handling is another area that I am not super comfortable with GoLang. So Go uses errors for handling exceptional situations. Okay, so when something does not work in a function, you can choose to return an error as opposed to the result. And there's a way to capture that error. So we're going to have to make a new function. The way that we can do this is let's make a function first. Let's call this function down here, let's call this function divide. Let's write a comment for this actually. This function will perform division on with two numbers, and the args are going to be args will be two numbers, so let's just call this a int, or we won't declare the first one. Let's just do a, and then b is going to be float 64. How about that? Okay, so I think I can do Annie here. Let's see what that does. Okay, and this will return float 64 and error. Okay, so the definition of this function will be func divide a b. B will have a type of float 64, and then the return type will be float 64, and then error. Error is its own type. So like that. If I hover over this, let's see what our documentation looks like. Cool. I don't like the way that this, okay, that's better. Okay, so we need to check to see, when we do this division thing, we need to check to see if the incoming number for B, which is going to be the divisor, if it's zero. If it's zero, you can't divide by zero anytime. So that's going to be an error. So that's like, it's like ninth grade math. At least it was when I was in school. So check if the divisor is, if the divisor, which is B, is zero. Okay, so if B equals zero, then if it is, return an error with a descriptive message. Okay, and then we're going to use this thing called error f. So this will create an error value for us with the message. So we don't have to like make this error object. There's actually something that will give it to us. And then let me write a comment here actually. So the fnt.errorf function will create an error with a specific given value, and we can control what that that message is. So the way it looks is return 0 fmt.error, and then the error message is going to be division, make this capitalized, by 0. By the way, in GoLang, you can return more than one thing. I forget what this is called. This is called a tuple. I don't know what this is called. Like, let's see, returning multiple things in GoLang. There's a word for that. I don't remember what that's called. I know Python can do it as well. I just forget what that feature is called. Doesn't seem to be telling me in this either. Do not use ChatGPT. I gotta be honest with you. I do use ChatGPT a lot. Like I mentioned before, my goal with this series is to not use it because the struggle zone is where you learn. Um, I'm not going to stress too much about the terminology here. Just know that if your function returns multiple things, you can destructure them wherever you're using a function to assign a variable, wherever you're executing it. So that's the main thing to remember. And these things here, separated by commas in the return statement. So when I go up top again to reuse this function, I can actually pull out both these values, which are the return types that are defined right here. Okay, so just remember that. Okay, so this is what happens if b is 0, because you can't divide by 0. And then if divisor is not 0, then perform the division and return the result. In this case, error will be nil, because there's no error, okay? What's going on here? Oh, I need a return statement still. Okay, so return a divided by b, and then we also need nil. Okay, cool beans. What is this saying? Oh, wait, error strings should not be cap. Oh, it doesn't want me to capitalize. Okay, have it your way. Have it your way. What else? Error string should not end with punctuation. Okay, jeez. I didn't know you were so picky. Okay, so now we have to use the function. Um, this error thing that we're using down here, error f, it's coming from this same import that we used earlier, the format one. So we don't have to worry about doing anything extra for that. Now we can actually use our function here. So to use our function, we will just assign it to a variable. So result, comma error, because we're destructuring. Let's just do ERR for short, and then divide, and then the two numbers we want to divide is 10 and 0. Okay, and then let's console log this. Let's so with GoLang, you will use conditionals. My English is doing bad. We'll use conditionals in order to handle errors. So if there is an error, if this thing right here has anything but nil in it, then that means we're gonna basically initialize the condition for that. And if not, then we'll do something else. So if error is not equal to nil, which means that there is an error, then fmt.print line error. Okay, so otherwise, we'll do else here. Fmt dot print line results like that. So let's write some comments. If there is an error, or if error is nil, that means there is an error. And then I think I can do the else. No, the else has to be on its own thing. Let me do the comment. I don't like that you have to do it like that. Let's do a comment here. If if error is not if error is nil, then there is no error, which means the function ran without an issue. Okay, cool beans. Put that in there. Okay, let's run this. And we can see that right now, because we're trying to divide by 0, we're getting the error. If we simply change this to 2, then we should see the result is 5. 10 divided by 2 is 5. So this is how we handle errors. Errors are just in my limited experience working on like my two servers that I built, using nil and these error messages is basically how you do it. There's some other tooling I found that is specific to like servers and like server error messages and stuff like that, but this is basically the way that you can find like an exception and capture it. This is kind of similar to the dot catch. I don't know if there's a dot catch in GoLang. I just have not used one in the things that I've been using to learn so far. So that's yet to be seen. I'll have to look that up for next time though. Okay, so ooh, this has been an hour and 39 minutes. We're really getting our reps in today. We're gonna be buff. We're gonna be built and buff by the summertime. I'm telling you. Okay, let's do defer panic. Now, I keep saying every time I do something, this is a thing I don't know that well. I really, 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 really this is new to me, defer and panic, okay? Um, but it's on my list. So defer is used to schedule a function call. Oop, gotta make this comment. To run after the surrounding function returns. I believe that this might be equivalent to like async await to some degree because you can use this as a way to ensure that something before has finished before doing the next thing. But don't quote me on that. But that's kind of what my example is here. Um, the way that this is going to look is defer as a keyword before a thing. So in this case, let's just keep it simple. Print line, and then let's just do deferred statement. So this isn't really going to do anything exceptional right now. I'm actually going to show you this in the context of creating some type of file, which will cause us to like actually. I'll just show you. I don't know if I can explain it yet. But the one difference is that you'll probably notice here is like the defer. There is some time that happens here. It's so fast though that you don't really notice it. But you can see here in the console log at least, without the defer in front of it, it immediately will just go ahead and create these console logs back to back. And then when we put defer in front, there's a space here. I don't know why this space exists, but I think it is kind of indicative of the fact that something happens, there's a waiting period, and then the next thing happens, okay? Um, so I think I have a better example. Um, so let's make another thing here. So file, error. This is going to allow us to create a new file inside of our repo here. That's what we're going to do. So file, error, and then we'll do os.create. This is how we create a new file. And by default, it's going to point to the directory that our program runs inside of. And for main.go, it's at the root level. You can put a path here, but we're not going to do that. We're just going to do example.txt. And you see here we're getting an error for OS because we have not defined this. This is an import. So we got to go up here and add another import, just OS. There's no commas between this, by the way. So put a comma here, you're going to get an error. Okay, so we're doing OS. And then this is all you need to make a file. This file will be empty, of course, but it'll make a file nonetheless. Okay, so when this happens, if there is an error, then we want to print an error. So fmt.print line error creating file. Okay. And then when we do this, we want to return because this will actually end our program, like the entire main.go program. So that, because when we create a file, it actually will open the file. It'll create I think it creates a thread. That thread remains open until we close it. And if there is an error and the program throws an exception and things go awry, I believe that is still open. That thread is still open. something like that. The point is that we actually have to tell it to close the file when main exits, okay? So that's kind of the point here. We need to return to end this function when there's an error, but then more importantly, we need to defer file.close. So what we're saying here is this will close the file when main exits, okay? This will happen regardless of whether this error occurs or not. This defer will still happen in both cases. Okay. So defer is used for cleanup operations like closing a file. Okay, so let's run this. There will not be an error here, of course, but we will see that this will close. Actually, I don't know if we'll see anything necessarily, but just know that it's closed. Okay, so we have a new file here. This file is empty. I don't know how to force this to throw an error to show you. Maybe that's something I'll play around with later on. So you'll take my word for it for now. So this is kind of similar as with a lot of other languages when you're like doing things like creating files and manipulating files and stuff. They remain open until they're closed, and it is the actual runtime that keeps it open. Now, I don't know anything beyond that, but I do know that that's like a pretty consistent thing. Okay, so let's just put another console log underneath this here. That's what I have in my notes at least. One thing you can see here too is that the order of these console logs are they're out of order, right? So you can see here this deferred statement that I wrote first in my console here is actually last. So this deferred statement is going to happen after all this other stuff runs. So just remember when you say defer, you're saying, hey, defer, you're going to wait until everything else is done, and then you're going to happen at the end, okay? So if you do a deferred console log somewhere, a deferred code to run somewhere else, it's not going to run in the sequence that you're writing in your code. It is going to wait. And I believe that the defers will run in the order in which they're written still, but yeah, so that's just like something to play around with. Like I said, I'm not expert at that part. This is the newest part of all this for me. Um, but I do see how this could be really useful, especially in like server side development. Okay, so um, I think, oh, I got to do panic. Panic is another one. Panic is a scenario where you have a function that throws an error. And panic is like the opposite of defer, I think. Let's just play around with it and see. Once again, something I am not super valued or super experienced with. I'm actually going to do this before my defer stuff. I actually have it in my note before the defer stuff, so let me do it right here. Okay, so um, we'll look at that. Panic will indicate a critical error. Let's just look this up real quick. I want to make sure I'm doing this or understanding this correctly. Trying to read documentation and do this stream at the same time, like I think that combination gives me like a lot of anxiety, by the way. So I find that when I'm streaming, it's hard for me to focus on reading because I'm just like, oh, I gotta focus on the stream part and I don't want to leave you in awkward silence. Um, oh, this is like a blog. I actually want to see the real documentation. Let's see what this says. Panic is just like an exception. It also arises at runtime. In other words, panic means an unexpected condition arises in your due to execution program is terminated. Sometimes panic occurs at runtime when a specific situation arises like out of bounds. It's an inbuilt function which is defined under the built-in function. Terminates a flow control. Okay, so it just terminates the control flow. It would be like, um, okay, I see. It would be kind of like equivalent to return, but it's not returning a value. It's just saying, hey, we need to end this for whatever reason. We don't want the rest of the code to run. I can see how this could be useful in situations where you're like dealing with like maybe like databases or something, or you have like a sensitive chain of operations, and some of those operations may be like not very sensitive to breaking conditions, and but you know that there could be something that breaks it, so like you want to put a panic there to manually. I can imagine scenarios like that. Maybe those that's not the best written code, but that's like a real thing. So value, let's just do something simple. So value five. We want to panic if the value is less than zero. So if value is less than zero, we want fmt.print line received a negative value. This is a critical error. We need some emojis here. We need an alert emoji. It looks really tiny. That's so cute. Okay, so this is a critical error, and because of this error, we want to panic. Let's say critical error occurred. Okay, so let's go ahead and run this. This should be fairly straightforward, but you can see here that we got this critical error occurred, and none of my other code ran. So this will stop the rest of your code from running. Okay, this is like you are forcing an error message to bubble up to your runtime, no matter where your code is, and nothing else after this will run. Um, what more should I say? Okay. And this will even block your deferred messages here as well. So like literally nothing else will run after you do a panic. Capiche, caposh, capuche. I'm actually going to comment this out just for the sake of putting this inside of the, let me just put a message here on comment the lines below. I'm going to leave this commented out just for the sake of putting this on GitHub so that it does not cause confusion when you try to run this code. Make sure this, yeah. I imagine that someone might go and clone this repo and then try to run it and be like, oh, this file doesn't work. How did you do your live stream? Okay, so I think that pretty much covers everything. Well, what do you know? Look, we're so clever. We are so smart. We just finished the stream. Okay. For some reason, I thought I had a lot more left. My sense of time could use some work. Okay. So there we go. There's our tutorial. We did 10 different parts. We looked at 10 different things. We've been on here for almost 2 hours. It's been an hour and 52 minutes. We had one break. Let me just say, I'm glad to be back here. I have two other streams planned. They're already put together, the code examples and everything. Basically, this type of thing has already been created. So all I have to do is just show up. You know what I'm saying? We'll see how far this goes. I've been using GoLang on and off for a long time. I've been very non-committal to it. So it is my goal to be consistent. I don't need to stream every single day, but I'm definitely going to try to keep doing this. I will keep doing this, okay? And yeah. Should I keep rambling or should I get off here? I think I'm just going to go ahead and get off. So thank you for coming by. This was GoLang number 1 in the OpenPair GoLang series. This is just a little introduction. Um, what are some footnotes? Okay. So as far as like this thing goes, I will occasionally take clips from these live streams and turn them into videos. If I like watch these and there's like some particular section, I'm like, oh yeah, that was really popping, that was really lit. I may come back, download the video, and take those little clips and put them together as like individual YouTube video tutorials or whatever that they're useful for. The little clips, but that's not the main focus. My main focus is just to get on here, stream, and get off and do my business and keep it pushing. So that secondary content is not a guarantee. But I will tell you that just like before, I imagine that as I dive deeper into this topic and just kind of get back into my groove, that this content will definitely get nice. And I will probably revisit content in the form of a stream at least, just to revisit it in a nicer, cleaner format. Maybe make quicker stream videos too. So we're going to see how this goes. I ain't got no kind of plan. I'm just showing up. I'm just doing it. I'm making it work. Thank you for stopping by. Thank you for watching. Don't forget to check down in the description. Give this video a like, comment, share, all that good stuff. Whatever people be saying with their videos, you know what I'm saying? This social media